Okay, this is the third example that we're going to look through in this session. Again, you need to have a good idea of what sort of trig identities are. We know that there's one to do with cot and cosec. When you look at cot and cosec, you suddenly think, yeah, it's the trig identity, the basic one, because we've got a squared going on, and it's got these reciprocals involved, the reciprocal functions. So we know we're in down here to have a look. So we know we're related to this function. So if you need to, you can then do these derives again. Remember how to find them. Divide through by, in this case, divide through by sine. This one, divide through by cos. And the one we need is that one. So we now look at this and think, right, we need to rearrange this in the form of a cot squared. So let's remove the cot to the other side. Is x minus 2, which means that cot squared t is x minus 2 all squared. We've got the cosec squared, so we just need to move that to the other side. And that is equal to y plus 2. Use the identity to drop the values in, so we've got x minus 2 all squared plus 1 must equal my y plus 2. Rearrange, get everything together, so we've got x squared minus 4x plus 4 plus 1 minus 2 is equal to y. Something's going on with my board. Give me a moment to see if we can clean it. The typing was, the writing was getting a little bit scrubbly, and it was the board interrupting. So we now simplify it to minus 4x squared plus 3 is equal to y. Find the equation of the curve. Second part, state the domain for which the curve has been defined. So defining where the curve is defined, they go on just assume that it's defined for all values of r. I'd like to prove it. So using dx dt, we get, can we differentiate cot? So I'll check our notes. Yeah, I can differentiate cot. That gives me minus cosec squared of x, or sorry, of t in this case. And try it for our values. So when t equals 0, we want to find out, sorry, first one is try when t is 0 into there. So I'll come back to the dx dt one just to make sure there's nothing else going on. Let's try cot of 0 plus 2. So x when t equals 0. Cot is 1 over 10. 10 of 0 is 0, so this goes to infinity. And try when it's pi. Which is 1 over 10 pi plus 2. 10 of pi is another, gives us another 0, which leads to another infinity. What we need to work through is find out, is there any minimum point? If not, it's going to be from minus infinity to plus infinity because of the nature of the tans. So dx dt, I'm getting here hesitations again, is minus cosec t squared and let's see if we can make this equal to 0. So we're looking at cosec, which is 1 over sine squared of t. Is that ever equal to 0? No, there is no solution for t. So there is no other value that we can have. So it is between for all real values. So this actually is our demonstration that there is no other limiting values apart from what the cot at t does. So this says we are defined for x belongs to all real numbers. Next bit to look for, just trying to get rid of, I've got processes running that are causing me problems. So x for all our x belongs to real numbers. Don't know why it's being slow now. Last part of it is to try and draw the graph. Hence sketch the curve. Well, we're sketching the curve from a quadratic. So we use our standard methods for doing it. There we go. First thing to look at is, do we know, what do we know from this form? Well, from this form we know that that is the intercept. So we go through 3. Can we factorize it? X minus 1 and x minus 3. That gives me 2 values which are roots. So we get through 1 and 3. Line of symmetry therefore is down that line of 2. You can also find the line of symmetry by doing complete the square, which is x minus 2 all squared. Subtract the square of that off and add 3. And it also tells me where the minimum point when I do this, as long as there's not a coefficient out here, we're going to, this bracket equals 0, so x is 2, and the minus 4 plus 3 is minus 1, so it gives me a coordinate there as well. So we now know we've got our parabola. We might want to find out, can we find the range? We know that it's valid for all x. What about what happens with y? So cos x squared, we want to differentiate cos x squared. Is that one we can do to 4? Because there isn't an equivalent. I could probably try doing it through a multiplication of cosec and cosec. Don't need to know what the t is when that is R2.